Okay, well, good morning. So remember yesterday what we did, had the introduction where I just went over some general apologetics, some ideas on apologetics and what I think the limitations are and what sorts of things I think you should keep in mind. Then what we did is we looked at, and I stressed this, that epistemology was so important for everything that follows, and I think when it comes to apologetics, not knowing epistemology leads to all kinds of problems, all kinds of errors on both sides, on Christians on our side, as well as on the unbelievers' side. So it really is worth our while to go through some of those issues. Now, what I'm going to talk about today for both lectures is going to be a little more specific, and it'll have to do with science in particular. Now, here's what I want you to realize. This isn't one of those things where you have to be interested in science to understand it. You don't have to be interested in science for this to be relevant. This is something, and I alluded to this before, there are a number of studies that show that scientists, most of them are human, and so they're going to have the same epistemic capabilities as other humans, so they're going to be using those, strangely enough, to get at scientific truth. Now, the other thing, and I'm going to point this out, is that the scientific reasoning really isn't special in any general sense. It's what we all do. We use reason, we use our cognitive faculties. This gives us an opportunity to further analyze our own and understand our own way of coming to the truth. Okay, so this first talk, I'll be talking about the scientific method, and there really is, that's a misnomer. There is no the scientific method, but keep in mind what I want you to get out of this is, how do scientists come up with their theories? How do they come to hold them, and how do they give up theories and replace them with new ones? That's really, really important. And what we're going to see is it's very much like, well, it's almost identical to the way we change worldviews. And even when it comes to specific beliefs, when we get new beliefs, oftentimes we're doing these are little micro theories that we're overturning when we come to change our minds about things. So this is all very, very relevant to everything that you do. And you'll see, and there's probably a number of you here who are interested in theology. And so we'll see that, in fact, this notion of coming up with theories is really what we do in theology as well. So we could replace a lot of this with just the science part with, no, this is just theology. And it's going to boil down to one thing. So I want you to remember this. Interpretation. It's going to be the interpretation of data. So hermeneutics is going to be very important, because hermeneutics is just your rules of interpretation. Not the specific term, but the rules of interpretation. So when it comes to science, when it comes to theology, when it comes to just about everything, it's all about interpreting the data and which hermeneutic should you be using, which is the best hermeneutic for interpreting that data, okay? All right, now when it comes to science, so how does science know? There's two questions I want us to keep separate. I mean, they blend, but two questions I want us to keep separate, at least in the back of our minds. Remember I said yesterday there were a number of questions, and usually my starting off point when it comes to understanding Christian apologetics. The first one was the potential defeat, or the attack on us, that says belief in God or belief in Christianity is irrational because there's no evidence. Well, we looked a little bit about what at the notion of evidence, maybe, an argument, and the notion of rationality. Now, the next question is just, does science, or the next objection is, science shows that God doesn't exist, or science shows that Christianity is false. Those are the two different questions, though, that I want us to keep in mind, the two different issues. There's whether or not science shows that there's no God, whether it be the Muslim God, Jewish God, whatever it is, that God of Abraham, Isaac, and Jacob, some, impersonal deity, an entity, a power, or something. That's one question, a general theism. Does science show that there's no God? Then there's the question of, what about the particulars of Christianity? Say the first chapters of Genesis, for example. That's obviously a big one. Does contemporary science, show that those first chapters are in some way false, unreliable, and therefore undermining the Christian faith? I'm going to focus mostly on theism. I mean, I've got a lot of opinions on the other, but I'm going to focus on does science do anything to suggest that there's no God? Let me give you the short answer. No. Okay, we're done. So let's go into that. Keep those two questions, those two issues separate. What we're going to see, though, when we look at science and how it behaves and how we form scientific theories, or how scientists form scientific theories, science is a lot harder than we think it is. And I want us to, part of this is I want us to appreciate what scientists do and the enormity of their task. It really ought not to work. We ought not be able to understand the subatomic realm. The very fact that we do is a gift. The very fact that we can understand these really esoteric ideas that go on behind the scenes of reality is something that we ought not to expect. But it happens. This is a user-friendly universe. So as we're going through this, I want you to see how difficult science is. The fact that we even get anything right is a miracle. Keep that in mind. That's very, very important. I mean, science to me is just the fact of science, the scientific endeavor and its success, to me just screams design, just generically. Design, design, design. Okay. There's a distinction that is so important. And again, I'm giving you high-yield concepts. These are the things that, if you were so inclined, you might want to tattoo on you somewhere. Hopefully you wouldn't do that, but they're that important. If you're going to do that, do it in Hebrew, because that makes it look more spiritual. So this distinction, there's a distinction in these two concepts. Observation versus theory. This shows up everywhere. Once you have this concept, this structure in your mind, and you start applying it to things, you start realizing, oh wow, this is everywhere. Okay, so it behooves us to go through this. Let me give you an example to explain it. Okay, think back to the Galileo Copernican debate. So you have there's a debate in Galileo's time that got him in some seriously hot water, whether or not the Earth moves. Is the Earth stationary or is it not? Well, you have two sides of the debate. Okay. Now, each side had the same exact observations for the most part. So they're looking at the sun here. They're looking at the sun here at another time. They're looking at the sun here at another time. And they can all go, hey, no matter what team you're on, Team Galileo or Team Aristotle, what you do is you say, hey, you agree that the sun's there? Yeah, oh yeah. Right. There's no debate over that. The stars are here. When you're watching, let's say Mars, over the course of a few months, you see it in the sky doing certain things, maybe retrograde motion coming back, curious things, but we all agree on that. Those are the observations. Those are the things that you just see. You can point to them. Now, on the other hand, what you have are the explanations for why do things appear that way? You know, why do we have these particular observations? You know, why on Earth does, well, I wouldn't be on Earth. Why on Mars does Mars make this retrograde motion? That doesn't make any sense or it makes, how about this? It's a very complicated explanation on an Aristotelian or Ptolemaic view. So that's one explanation. The Aristotelian view, the Ptolemaic view, is one explanation for why things appear that way. Then you have the Copernican view. Well, that's another explanation for why things appear that way. It's not that the Earth is stationary and everything is going around. The Earth is moving as well as Mars. Two different explanations for the observations. Those explanations just are theories. That's what we call theories. Theories are inferred explanations that help us understand what's going on behind the scenes. One of my favorite pictures is the Flammarion engraving. Sometime Google that. It shows, it's from the 1800s. It shows like a shepherd poking his head through the veil of the universe, looking at the gears behind the appearances. And it's a really fascinating, I mean, and it pretty much sums up this distinction. Okay, so you have theory and you have observation. Notice oftentimes there's not much disagreement here. This is where all the action is. This is where all the disagreement lies. You can't point to, even now, you can't go, all right, everyone, let's look at the Earth moving. You can't do that. Even with all our data, we have not ever observed directly that the Earth moves. We've seen relative motion. Well, we haven't seen it directly. There's so many things, and this is one of those concepts that just unlocks a lot of things. What have we actually observed? You'd be surprised. So much of life and importance goes on here. Do you remember the foundation, my building metaphor? So this would be maybe the foundation, and a lot of this would be, the theories would be in the building, the superstructure, the things that you infer. Now here's the problem. What I'm going to do is what I'm going to do from now on, for the next, 20 minutes or so, I'm going to show you why science is difficult and why theology is difficult. Why there are, say, 38,000 Protestant denominations. It's because of this, there's an enormous gap in between these. So really they look like they're just together. They're not. You have, we'll use O and T. That'll save us some time. And I'm always looking for ways to save time. Observation, theory. How do you go from here to here? Do you use reason? Do you use sense perception? We only have so many tools. How do you go from all the observations to Copernicanism, to Aristotelianism, to Tycho Brahe's there was a third view too, that was mathematically equivalent to the Copernican view. So just as good, and it kept the Earth stationary. So how do you bridge this gap? That's where all the fun is in science. So the theories are they're telling us what goes on behind the scenes. Imagine your watch. So imagine you didn't really understand how watches worked, but you knew how to use one. So you knew that, so you have this motion. For you guys, it's going this way. So you have this motion. You know how to use it, and it's accurate and all of that. That's the observation. The coming up with a theory is trying to guess, almost, okay, what do the insides of that watch look like? I've never seen a watch, the insides of a watch, let's say. Now I've got to figure out, and I never, ever, ever have access, or very rarely have access. I can't take the watch apart. I've got to just figure out, based on the workings of the face, what's going on inside. Welcome to science. So as an aside, I said this had to do with theology. Think about it this way. We do the same thing in theology. We go from observation, and for us, the observation, the data, is Scripture. Okay, so we have the data of Scripture, and we can all point to what the words are, what the data is, let's say. Then our theology is the theory, the inferences that we make, but the entire collection of inferences that we make from that data. Okay? So the doctrine of the Trinity. So let's see how what if I said, you know what? The Trinity is just a theory. That's going to, you're like, whoa, what do you mean just a theory? Well, there's an aside here. When someone says evolution is just a theory or general relativity is just a theory, well, yeah, but what else do you expect? Any theory that we have is just a theory. The question is how well did we bridge this gap? So the doctrine of the Trinity, you can't read off of the data the doctrine of the Trinity. But it's the best explanation for that data. So what we've done is we've bridged that gap. We've taken the data here and come up with theory, which is the Trinity. And we do that for all of our doctrines, or at least most of the ones that we don't read directly off of the data. Now, here's what I want you to realize. Whether it's science, going from observation to theory, or theology, observation to theory, or we'll see in a moment, just your ordinary life, you're going from observation to theory, it requires a hermeneutic. There's got to be rules to get you through from one side to another to be able to bridge that gap. Hermeneutics is wildly important. It's amazing how pervasive it is. Okay, now I said that there's the scientific theory. But there is, we have all heard of and studied and learned the kind of G-rated version of the scientific theory. The version that's safe and nice. And there's something to that, and I think we can use that and then move out from there. And we're going to see it's not just the scientific method, it's going to be the theological method as well. So, 4 steps. First one, we have observation. So we observe the data, we look at things. Second, we come up with a hypothesis, which just is the theory. Okay, but normally we call this, in science, a hypothesis. But it's really the theory. In a theory, a hypothesis is just an unobserved explanation. That's what a theory is. You can't see it. You can't point to it. You can't go, okay, here's the theory of general relativity. Here's the theory of the Trinity. You don't point to that's not the kind of things you do with theories. So a hypothesis is the unobserved explanation. Then you have this theory. So here's remember, we're going to do this over here. OT, remember, observation and theory. And then we make a prediction based on that. And we say, okay, well, if that's true, if the theory happens to be true, what sorts of things should I see? What other things should I see? So you make a prediction. Sometimes it's a mathematical prediction. You follow the math and you get these results and you go, whoa, that's weird. If that's true, light should bend around things like this, like stars. So that's one weird prediction, let's say, for general relativity. Then what I do is I want to say, well, okay, let's test this prediction. So let's see if it comes about. Let's see if I can make this new observation. So this prediction is going to be, we'll call this O new, the new observation. And then I perform, let's say, some sort of experiment. It might be very, very simple, like I just go look for something else, look in a different place. Or it might be elaborate. It might be like the CERN over here near Geneva, the particle accelerator that's just one of the most amazing instruments humans have ever devised. And you see whether or not you get the new observation. And then if you do, you know, hey, I'm onto something. If you don't, oops. And so that, hey, I'm onto something versus the oops, that's also where a lot of complexity enters in. So here's what I want to do. So giving this as kind of our skeleton, I want to point out some of the ways in which this becomes really complicated. And it's not just a simple matter. And it's not really a simple matter anywhere along this. Even the observations, when we talk about the CERN complex, you know, making the observations is super complicated. Now, let's talk about this first step. The step between 1 and 2, between observation and hypothesis, or observation and theory. Remember, that was the big gap. How do I make that jump? The main way that we do this, there's a special phrase for this kind of reasoning. It's called inference to the best explanation. Inference to the best explanation. Okay? Inference to the best explanation. And we saw that, how this works. You take all these observations, you take this phenomena, and then you go, okay, what do I think is the best, given everything that I know, including the observations, but here's what's important, and including all of my background beliefs and all of my experiences, maybe even my temperament and my personality. I come up and I decide, all right, given these observations, what is the best theory or the best explanation? Because remember, theory is just this unobserved explanation. The unobserved part is it's critical. It's not over here, it's over there. There can be explanations that are observed. Let's say I want to know, what that noise was, that sounded like glass breaking. And I went over there and I looked at it and I see, I find the story, someone had tripped or they fell and they dropped the glass, and I see, there's a sense in which I see what happened. Or if there's a videotape of it, I see what happened. That's observed. It's no longer a theory or a hypothesis, but it is an explanation. So the unobserved part is that's the not being able to see it, like the inner workings of the watch. That's why it's so hard. Okay, so this step uses inference to the best explanation. Now here's what makes some of this so fun. coming up with a theory, is that there are multiple possible theories. So given one set of data, one set of observations, I can come up with different possible theories. So I have a number to choose from. Some of them are really wild, like ridiculous, that I don't even consider. Others are pretty plausible, and sometimes there's two or more that are really plausible, and that really sets me thinking. Let's say, for example, I look out my back window, and I see that the door to my shed is open. Now I have tools in there that are expensive that I'd like to keep in that shed. So I look out there and I'm alarmed. I'm like, what? The door is open. Now there are a number of explanations for those observations. One could be that one of my children left the door open. Look, I've told you how many times to close that door. But lo and behold, they will sometimes make a mistake. Imagine that. They left the door open. Okay, that's one. And that's going to have certain ramifications. Hey guys, could you please, could you just make sure we want to keep that all in there? That's a lot of money. Or it could be someone jumped over my fence, which is pretty low, went and ransacked my shed and took some things. That's another one. It's going to have different. So that's another possible theory. Or, and this is becoming more and more likely, I left it open and I forgot. That's another theory. And that's a little that's actually becoming more alarming to me. So we have that, or it could have been aliens. Aliens could have come down and whatever. But notice there are a number of theories to choose from for my purchasing pleasure. I have a choice to make. And let's say, given there may be times, and there often are times, where that data will match, each theory will match that data perfectly, or equally well. How about this? Not perfectly, but equally well. So it's hard for me to choose. It's hard for me to choose which theory best explains it. This is called underdeterminism. When you have, so let's say you have observations, and you have multiple possible theories. So I could have that one, or that one, or that one. And unfortunately, it's ... So there's a lot of possible theories. You've seen this when it comes to anyone, if you remember from math class, let's say you have 2 points. I'd like to know how to connect that line. Let's say this is pressure, this is temperature. I'm an engineer and I want to figure out, I don't want to have to measure pressure and temperature all the time. What I want to do is I want to be able to have some way to calculate it. A theory. This is a little mini theory I want to come up with. Well, one of the ways I do that is I say, well, what's the best curve fit? What's well, in this case, I'm going to go, the simplest is the line. I'm just going to draw a line through it. But that need not be. There's a perfectly reasonable alternative to this, and it's that. Or that. And these are all the different T's. Now, in this case, it's pretty simple. What I'm going to do is I'm going to say, I need some more data to try to figure out which it is. And that's usually how you adjudicate this. But sometimes you can't. And so sometimes you have to say, okay, given the data that I have, what is the best theory? Who decides what's best? Let's say you and your scientific colleague, you're in a laboratory and there's 3 of you and you have the same data, you perform the same experiments, and each of you says, you know what, I think it can be explained this way. And the other, how do you decide amongst you? And this is what happens in the scientific community at large. And just any sort of disagreement with people over whether or not any type of disagreement is some sort of theory competition. Now they may be little theories, they don't, you can't, but they're unobserved. So for example, you can't point and go, all right, everyone come over here, we're going to see that abortion is wrong. That's a theory, and it depends on other things that go into it. So this gets really complicated. And I mean, this is such a simplistic view of it, and it's just wildly complicated. And so what you're doing is you're doing this, and I was so glad to see this. This is beautiful. I love this. Let's say you have two theories. Let's say that these are the bits of evidence, okay, for each theory. Now this is going to be, this applies to, again, worldviews, atheism, theism, Islam, Christianity. Any sort of disagreement, you have this balance. And every theory, every side has something to put in there. Otherwise, there wouldn't be a possible theory. So if some human entertains one of these, it's going to have at least something to go in here. Evolution, old Earth creationism. There's evidence over here, so we can't go, you know what, there's no evidence for unguided evolution. Well, that's not true. There's lots of evidence for it. There's lots of things you can put over here in that balance pan. But if you look at all the evidence, it may be that much more goes into this side. And so that's what we're doing when it comes to these theories. We're having to figure out what is the best, but sometimes the observations, you can't tell a difference. So you have to defer to other things. So both of these, so in the time of Galileo, all the observations seemed to, there was a kind of they came to loggerheads. It was like, you know what, there are no observations that can adjudicate between an Earth moving or an Earth being stationary. And so you have to defer to other things like, well, what's the simplest theory? What theory accords best with other things I believe? Like my belief in the Aristotelian corpus. I mean, that's pretty impressive. And Aristotle said that the Earth is stationary, and he has really good reasons. The Bible, that's another background belief that I want to hold on to, so that's in accord. So stationary Earth is in accord with that. The other is, come on, guys, I don't feel anything moving. I drop things, everything seems stationary. So it just seems like what I do is a stationary Earth, for example, seems to accord better with other background beliefs that I have. So I'm choosing best. Notice this, I'm choosing best not based entirely on reason or on observation, because observations match identically. I'm choosing it based on other things I believe. Here's a good example. This happens in contemporary science. When general relativity and quantum theory, let me do something really quick. You can throw around those terms, and it's just, they mean almost nothing. Can I show you all of physics? I'm going to show. So here's physics in a nutshell. There was Newtonian physics. That's the physics that you learned. Then in the early 1900s comes along the people like Einstein and Niels Bohr and Heisenberg come along and say, you know what, that's not really correct. It's a good approximation a lot of times, but really this has to be replaced with general relativity and quantum mechanics. Now these are our two theories. This is just a good approximation for ordinary garden variety objects. This is when things get really fast and big, and this is when things get really, really small. You need both of these. So these are our two pillars of physics. There, that's it. That's physics. Einstein came up with this. He was very much against this in certain respects. Do you know why? Well, quantum mechanics says something really weird and spooky about the subatomic realm. Particles aren't really particles. We think of like little electrons, like a little thing here, and then, you know, they have location and speed and all of that. Well, according to quantum mechanics, or at least the major interpretations of it, a particle could be a little bit over here, a little bit over here, or both there and here. It doesn't, they don't really behave as particles, and you can't really say whether or not it's a particle. Some people think, you know what, remember, it sounds like we're talking about particles, but it's kind of like Jabberwocky, 'twas brillig in the slithy tove. It kind of sounds like you just said something grammatical, but you really just said nonsense. Well, we talk about particles. Well, really, these particles aren't particles, they're slithy toves. I can use them in grammatical sentences, but they're bizarre. And Einstein said, look, there's something wrong with this. You know why? God doesn't play dice. The world can't be like that. Now, why did he think the world can't be like that? Well, it had nothing to do with his science. It had to do with his background assumptions. So his background assumptions, he's choosing what's best, and it's not this theory. It was some theory, I know not what. You know, there wasn't another alternative yet. So he said, this is wrong because of my background. It doesn't comport with my background beliefs. Notice that. The man who came up with this was wrong about this because of some background assumptions. And he's notorious for being wrong about this. So your background beliefs go into deciding what's best. There is so much subjectivity when it comes to science. And notice what we've been doing. We've only talked about this gap right here. Now, let's say you want to go to, and we'll try to wrap this up really quickly. Going from prediction to experiment. You would think, okay, well, once I have a theory, it's pretty easy to tell whether or not the theory is true as long as I can do some experiments. Alas. Let's say you have the case where you have a prediction. So the prediction is, given the theory, I get this new, I ought to get this new observation. Okay, so that's my prediction. If this theory is true, then I ought to observe this. Let's cook up an experiment and see if I get this new observation. And let's say I do. Let's say so if general relativity is true, then light ought to bend. And let's say light indeed does bend. Well, what am I going to think? Yay, I know the general relativity is correct. Here's the problem. There's a logical problem, and it has to do with the underdetermination. So you have, on the one hand, here's the positive evidence, theory, thumbs up. We call that confirmation. Well, the logic of it, okay, Now, watch what we do here. I'm going to use a logical symbol. If P, then Q. This little sideways horseshoe is just an if-then statement. Okay, if P, then Q. Well, let's say, here's what the logic would look like. If T, if the theory is true, then I would get the new observation, right? And in this case, in the confirmation, I did get the new observation, light bent. Therefore, I concluded that, so you have these premises and a conclusion. If the theory is true, then I get this. I should get this. Well, in fact, I do get this. Therefore, I get this. There's one problem with this. This is invalid as a deductive argument. This is an invalid argument. So it could be that you get this light bending, but it could be that there's some other theory. Remember, we had T1, T2, T3 that equally match observations. It could be T1, T2, T3. So it's really, now, that's not to say that there's nothing to this, that there's nothing to this argument, because it's really an inductive argument. It gives us good reason to believe. But because of that underdetermination and the multiple theories, you can't be sure. This happens in real life. So you have to be very, very careful not to get too excited if you get your new observation. So you might be onto something. That's good. That's great. But hold your horses. Don't pop the champagne just yet. Now, when do you pop the champagne? At what point do you get enough news, the new observations, to finally go, we got this in the bag? The lab coat. Everyone's in the lab coats with their champagne or what? Champagne. Champagne. Okay, so that's one problem. The other is, well, what about, so it might be, let's look at the negative side. This is called disconfirmation. We start with the same thing, with the prediction. If the theory's true, then we ought to get this guy. Now, here's what I do. Light doesn't bend, let's say. I don't get the prediction. I'm sad as a scientist. But what's nice about this is a valid argument, and I can know, like that, this is a not. This means not new observation. So I don't get this. I don't see this now. And I'm disappointed, but at least it's cut and dry. I know that, therefore, the theory is not true. It's not so easy. Because really you're really not just testing this. Neither are you testing it just here. You're testing all kinds of things with it called auxiliary hypotheses. I performed the experiment correctly. The beaker was clean. The laws of logic work. Now you might think, well, who's going to throw away the laws of logic? Well, quantum theorists are going to try. They're going to come up with something called quantum logic. So what you do is you really have A1 plus A2 plus A, all these auxiliary assumptions that you're testing along with us. So really all you know is, okay, I know it's not the case that the theory is true and I performed the experiment well, the laws of logic hold, the future will be like the past, all these assumptions. But you don't know which one is the bad apple. You have a bunch, you've tested this bunch of apples basically, the theory plus the auxiliary hypotheses, but you can't tell which one made the whole batch bad. And so oftentimes what scientists will do is they'll realize that some assumption that they had, that they were using along with the theory, was the wrong assumption, and so they tweak that. So the theory, they save the theory. So it's really hard to kill a theory. In fact, and that's a good thing. That's not like it's not scientists being really just stubborn. It's kind of like when you're married. If you separated at the first sign of problems, like the first argument, there would be very few people married. You want to make it work and give it a shot, and so you go, okay, how can I make this work? Well, maybe it was one of my auxiliary assumptions that was wrong. And that's how that Newtonian theory was saved for so long by that process. Okay, so what's the point? We'll see more in the next. I'm leading up to something that we'll talk about in the next lecture. This process, there's lots and lots of uncertainty. There's lots and lots of subjectivity that goes into deciding what's best. And sometimes it can sound like so it could be this kind, it sounds like it's almost like this kind of case. What's better, vanilla or chocolate? And some people go, it's objectively true that chocolate is better. I mean, what are you talking about? And someone goes, yeah, no, I don't think so. It's objectively true that, well, sometimes best depends on the kinds of things you value, the kinds of things you hold dear, the kinds of things that are just part of your temperament. All of those things. So this notion of best is very personal. Remember, I mentioned persons, and the notion of personhood is going to show up a lot. Well, again, science has a human face. Now, I don't say this just to go, well, therefore we can't trust science. In fact, I think there may be times when we ought to go, okay, well, I don't know if science is really right in that area because of these certain maneuvers that have been made here. But I'd better be able to say which maneuvers were the wrong ones. What I also want to do is to say, you know what? Scientists in many ways are heroes. To be able to come up with, the more you study science and the more you realize what we've discovered, you think there's no way people couldn't have done that. There's no way humans ought to have been able to do that. Wow. Yay, science. You know, I mean, that's kind of, I want you to appreciate science, not just go, yeah, you know what, you can't ever trust it. All right, so that I'll leave it there. And are there any questions or comments on that, on what we've said? I know this one was a little higher, but it's very, very important because remember, all of this same thing best applies to theology too. Person relative. That should make you a little nervous. It ought to. Like, whoa, wait. I want objective truth. Nothing I've said here is denying objective truth. It's epistemology, getting at the truth. Stephen, did you have a?
Yeah, I was just going back to theology now and how this might be applicable.
Yeah.
If most of theology is theory, you know, some of us are Presbyterians who rely heavily on confessions, theological confessions, and confessional subscription.
Right.
How important should that be, given that much of that is theory? How
Yeah.
much of a subscriptionist can one be if it's mostly theory?
Right.
Or best inference to the best explanation.
Right. And it's going to depend on how well this was done. Okay, so now you've got to figure out how do you do this well? This is going to be an issue that the church has to grapple with. The humans have to grapple with this. I've seen it time and time again, whether it's in people's personal lives or in their professional lives or in theological lives, is avoiding two sides. You're on a road, you're trying to avoid two sides of the ditches. Two sides. You know, there's a ditch on this side, there's a ditch on this side. So one thing would be to say, look, this is so subjective, we can't ever know. all bets are off. I'm going to go postmodern. Okay? Foucault, here I come. Or it's to ignore this and clamp down and just out of fear and go, no, I don't, you kind of cover it up. No, I got this theory right here. Well, what's that behind you? Nothing. So it's avoiding this overconfidence, but avoiding this lack of certainty that you can't. So notice I haven't answered this. What I've said is it's going to depend. This is one of the things that the church needs to grapple with, this interpretive plurality, the plurality of interpretations depends on this. This is why this is where hermeneutics happens. This is why hermeneutics is so important. This is one of the things that postmodern philosophy has gotten right. They've taken hermeneutics and they've applied it much more broadly, not just to literature, not just to text, but to epistemology in general. So this is a challenge. Anything else? Yeah, Will.
Thank you so much for what you said. I was thinking also it's maybe an aside to the lecture, but if you're talking to scientists and defend the theological method or even the historical method, they probably agree on you that in theology and history, observation and hypothesis are essential steps toward forming of new theories. But they say that theology and perhaps even historical method are missing the prediction and the experiment and are therefore not totally scientific, because it's hard to stick with the Trinity, it's hard to, on the basis of your Trinitarian dogmas, to make any predictions and conduct experiments.
Right,
so they'd say that theology is less scientific.
Sure. So the question, sorry I didn't repeat the first one. The question is, okay, these 4 steps are, you can see them clearly in science, and you can see these 2 steps clearly in theology, but it's not easy to see how you have these 2 steps in theology. Well, actually, one way to think about it, now you're right, you can't avoid the fact that there are, even though there is observation and theory, they are different realms. One's textual and the other isn't in a certain sense. So you're going to have to make some distinctions. However, I think you can have predictions. So what you can do is you say, all right, if let's say the doctrine of the Trinity is true, I should be able to take that and apply it to, I should be able to reconcile that with Scripture as I read other passages that I might not, because I didn't look at all of the passages in the Bible necessarily to come up with the doctrine of the Trinity. There are certain ones that you kind of focus on. But once I do that, I should say, once I come up with the doctrine of the Trinity, I should say it ought to comport with the rest of Scripture. There ought to not be something else in Scripture that I missed that ends up being against the Trinity. So there are going to be things where I can have kind of, maybe not a prediction. My prediction is it ought to be consistent as I read through it. And let's say I read through it and I find, whoa, this passage, and we do this with all kinds of doctrines. Paedobaptism. There's really good arguments, good data for getting paedobaptism. But then there are other passages, I might say, all right, well, I should comport with the rest of Scripture. Well, hey, what about this little one in Acts? Believe you and your household. It's just like you can believe it. Well, wait, that's for no, he was so you get these different interpretations. So you can have a kind of, you try to find an equilibrium with prediction. Did I see another hand?
More about the implication and some thought that I have now. Do you think that when we let the science that are that we call hard science call that themselves the science. We are in a way defeated ourselves because we put them in the other realm. But what we are saying here is that all knowledge, I think it's before the Enlightenment, but I'm not sure about the history. There was knowledge, science was everything.
Right, right.
And no problem that we have a theory in theology or in biology. And do you think that we ought to, in our mind, be in that position to better defend the faith?
Yeah, I think that's a great question. So if I'm understanding you correctly, we talk about science as some different discipline from everything else. But ought we is it really different from all other disciplines of knowledge? After all, before we had maybe the 1800s, before science became specifically this, what used to be called natural philosophy, you can have the science of anything. It's just, science is just an ordered body of knowledge. I think that's right, and I think one of the things to do, well, first of all, there's something called the demarcation problem in the philosophy of science, where they try to demarcate science from the rest of the realms, and that's usually in order to show that the rest of the disciplines aren't as solid as science. So creation science, for example, that's not science, that doesn't count as science. But it's very difficult in theory to come up with a definition of what science is. And that makes perfect sense. I mean, all truth is God's truth, and you're going to have, we're all human, and we all have these same cognitive faculties. So there's going to be, that's why we have this can apply to so many different areas. And I think the more we realize that the borders of disciplines are very vague. And in fact, sometimes they're not really even borders. You'll have in the middle of science all kinds of philosophy going on, all kinds of theology going on. So there's really not it's just a big, massive truth. And you're trying to get at it in certain different ways. And I think the more we realize the similarities, but also keeping in mind some of the differences, the better we're going to understand things like theology and science, and sometimes how hermeneutics goes with both. So I think you're right. Vlad, did you?
Yeah, I just had a question about the chart over there. When is the plus with the confirmation, is premise 1, then you have the premise 2, and you have a result. Why did you say at the end that it's not necessarily always correct? Because the way I see it, you follow all the steps. If you have a prediction followed by an experiment that is correct, that turns out to be right, you should be okay. Could you have different outcomes?
Yeah. Well, here's what you can have, let's say you have this observation, this new observation. There may be other theories that you haven't even considered that give this same observation. And that's because we had this notion here, this picture where we had theory 1, theory 2, theory 3. Now you may not know about these. These are all possible ones. I mean, there are probably an infinite number of them. We're just not clever enough. I mean, it's hard to come up with one. But they all might give a particular observation. So let's say you do get that. Because it was so difficult to come up with just one theory, you're thinking, whoa, I got this in the bag. This is great news. But really there are literally an infinite number of theories that would give you this just as well. So you're right, there is something to it, and you don't want to go, well, that's nothing. No, it usually is very good news. But the history of science shows us that what we took as good news sometimes, eventually it was like, there was a theory we hadn't considered. So Newtonian physics So in Newton gives you this theory, this observation. This happened so often, millions of times, where you're finally like, there's no way to overthrow this. But it turns out that general relativity gives you these same millions of observations too. So you just went through and you thought you were confirming Newtonian physics, but you were, in a sense you were, but you were really also confirming general relativity. And you may be even confirming some other future theory that we don't know of yet. And we'll talk about that in the next lecture. The general relativity and quantum mechanics aren't the last word. Yeah, Alex.
It was wonderful. Thank you very much. But maybe I haven't been listening very well, but maybe you'll get to this later. But I haven't heard you say how we could have any certainty.
Yeah.
Even the best inference is the best explanation. So you can defend the explanation as being the best explanation, and you said there was some subjectivity there.
Right.
But the best explanation isn't necessarily the true explanation.
Right. Exactly.
Unlikely it could be the true one.
Right.
So I'm kind of having a crisis of faith.
Yes. No. You're right. And so the question is, okay, we've been talking about this uncertainty. How do you put the brakes on this uncertainty? I'm saying you're having to avoid these ditches. Well, you haven't shown me how to avoid the ditch of complete skepticism. That is going to be something that we have to talk about. Some of it is going to depend on faith. You really are going to have to just trust certain things. And some of it is going to be given things that we all believe as a community. I mean, there's going to be subjectivity, but that doesn't mean that everything is equally reasonable. So reason will come into it. Observations will come into it. Simplicity will come into it. Values will come into it. So there's some objectivity, there's some subjectivity, and you're going to have to, given what you know about the world, and here's the thing, as Christians who believe that we've been designed by an infinite God to navigate this world successfully, we can kind of rest, say, okay, there really is a chair there. And we really have seen that lots of things we've said, look, there are many things we've gotten right in science. But we can't be overconfident. But as Christians, and this is one of the things why I said earlier, science seems to scream design. The fact that we can just get things right at all, which we do, is evidence that we've been graciously designed and put into this world that we can navigate in. The world's user-friendly, and our cognitive faculties are reliable. And because of our view, we can be confident of that. But you're right, if you don't have that, and this is one of the things that I argue in how to be an atheist. If you don't have that, you're right, you can't tap the brakes. See you, we'll see you in skepticism. And that's the word. So there's so much here, and there's so much that we're doing that's so critical and foundational that applies to everything you believe and do. And notice what we did. We were talking about science. Well, yeah, we were talking about science, but we really were talking about much more. Do we want to take one last one? One last one, Jonah?
Yeah, that's kind of related to what Alex had been saying as well. I want to back up, and I'm thinking about what you said yesterday concerning representationalism. And we're talking about foundations, foundational knowledge,
right?
Basic beliefs, I guess is
the
term you used.
Yeah.
But now, you had mentioned too that this inference to best explanation, the track record argument, some of these kinds of things, you end up in a kind of circularity.
Right.
Now we're going to inference to the best explanation. We have that kind of circularity.
Yes.
What I almost hear, maybe as an epistemologist, I'm hearing coherentism coming into this.
Sure.
Instead
Sure.
Of foundationalism. So
Right,
you have
right.
a belief,
So,
and it makes sense, it's coherent, but where's the foundation then?
right, right. Well, and that's a wonderful question. So you have this notion of, so the question is, how do you, so yesterday we talked about there being this, you can't argue for the reliability of your cognitive faculties without doing it circularly, without depending on those faculties. Yet we're now, in the inference of the best explanation didn't really work. You know, say, well, the best explanation for why I can navigate the world is that my cognitive faculties are reliable. That doesn't work. That depends on that sort of confidence. When you're trying to understand or confirm the use, the reliability of the tool, you're right. You're stuck. So what we've done between maybe this happened overnight. Between yesterday and today, what we did is we're assuming that our cognitive faculties are reliable, generally reliable. And that allows us to proceed into this realm without pure skepticism. But if you don't grant that, none of this matters. You just go, okay, but given the cognitive, that we're not talking any longer about our cognitive faculties, we can avoid the circularity. But unless you assume the reliability, you can't avoid it, and you never get out of the, which is why I think, hey, look, if you're a skeptic, you're an atheist, and you love David Hume. This is why I love David Hume so much. Not because I'm a skeptic or an atheist, but because I think, hey, follow him. You know, you want to take a walk with him, keep walking. Just walk, but you need to walk all the way down the path and see where it leads. And it does lead to that. You can't ever get out of the yesterday's conversation in order to get here. And Hume realized that, and he's like, okay, that wasn't what I expected. How do I get out of this? Oh, I know. Let's just assume that, we can't help but think our cognitive faculties are reliable. Nature's too strong. But Hume, you can't do that. You can't just assume that. You're trusting your senses, and yet you're at the same time you're showing him that you have to be skeptical about them. And he's like, hey, and he calls that the whimsical condition of mankind. So a land of whimsy. This is a world of whimsy for someone who doesn't have a designer, I think. Okay, well, thank you. We'll talk in a little while.